Okay, all right. Out of that, I don't know. I find it a little bit abstract and difficult to engage with
Go
from the,
ahead.
from the point of view of significance to everyday life. Yeah, also, what I don't like about this particular video tonight, he, I suppose he's got to do it, but he uses the sort of common, broad perceptions of the sort of normal model, which I think is always not always exactly true. He's got the hand up.
Yeah, I put my hand up. Um,
Yeah.
I just talking about infinity to that extent. I mean, that sounds like a meaningless statement to start with because infinity is infinity, and so it doesn't have an extent. Um, I just wonder, why do we doubt the infinity of the universe, either in size or in time? Why do we? What reason do we have for doubting it? How can we doubt it?
I think that's actually exactly the sort of theme and question that he was alluding to throughout the video is what he was saying. If the universe is infinite, then you've got all these problems where everything is possible at some stage, which means, how do you? I mean, to me, that's sort of it's true. Everything is possible, and how do you predict anything if everything's going to happen at some stage? Like these complete brains which just form out of something and float around in space, as one guy theorized. So, I mean, I think, we've still got our observable universe, and I think the laws of physics apply within that. And a lot of stuff is determined by the speed of light, and you're not going to have to deal with all these funny things generated by infinities, which will, in any case, happen over trillions and billions and trillions of years, which is sort of irrelevant to us.
Derek, it's possible that what you're saying on a practical level is absolutely correct, but I think this sort of just illustrates our inherent curiosity and our need to know more and to understand our world. So I think it's possibly a consequence of human nature that this speculation goes on. And, we want to understand and what were the other possibilities. So I think it could just be a version of a sort of illustration of that. It's not so much as a practical thing. We would just like to know.
Yeah, I think it's a bit of an exercise, this whole infinity thing. Like the whole thing is scaled. If the universe is like the size of a grain of sand, then what else is there outside the universe? Is there a big beach around the universe? Is the beach part of a big landmass? Is the landmass part of a continent? Is that part of a planet? Is the planet part of another big solar system? Is that part of a galaxy? Is that part of a And so it's mind-boggling if you just start imagining these things. But I think a couple of the people in this thing went crazy in the end, and I can understand why. If
Yeah,
you
yeah, it's also led by
now
mathematics.
that
So
you outpace your total time and so on.
yeah, the notion of infinity is a mathematical concept, and a lot of these cosmologists are mathematicians. And so trying to understand infinity can lead to these sorts of questions. And you also have to realize that in the past, curiosity has led to what we know now. We used to think that the world was entirely just Earth and the moon and the five planets, and that all the stars were just on the inside of something. And we have a completely different view now because people were curious and actually tried to find out. And this, I think, just may be an extension of that, even though maybe has no realistic or practical value.
I just think there are so many interesting problems and puzzles that are much closer to us, which we can sort out.
Yeah,
Not
agreed.
even
But
not even out on space, just on Earth. Just, just the biology of people. There's still stuff within the cell of a human being that we don't understand.
Yeah. But sometimes what's involved in looking for one, trying to understand one complex and very theoretical area can actually come up with solutions for more practical problems and issues.
Some of the analysis and views of the people are interesting, you must admit, like.
Yeah. But it does do your head in.
Yeah.
It certainly does mine.
Jenny, your comment about human curiosity is very true, and that will continue in future as well. I think John Saunders liked to say at the end of some of his talks, a very simple model of the size of the universe. If you start traveling from Earth, what do you find when you reach the edge of the universe? And it always shows a picture of a hamburger hut.
Yeah, a bit like, who was that author? Adams. What was his name? Richard Adams. Who said there was a, is that the come from that, the hamburger stand at the end of the universe?
The Douglas Adams.
Douglas Adams, thank you. Yeah.
Well, an interesting, let's call it philosophical or thought experiment. Thanks for showing it. I've got to go. I'm being called for supper. Our son is here. Good night, everyone.
Thank you. Okay. Cheers. All right, so for next time, we've got Why Does the Universe Look Like This is the title. So I think that's strings around and a little bit more down to earth and for me more interesting possibly.
Yeah.
And
That's certainly interesting. Thank you very much.
No. And after that, by the way, it's what are the hidden rules of the universe. So I think for those that are a bit fazed by the complexity and abstractness of tonight's one, I think the next couple will be more interesting.
Right, just one last thing.
Go ahead.
Yeah, just one last thing I wanted to ask Derek. He mentioned redshift. I think he said 70 kilometers per second per megaparsec. Now, at that rate of lowering of the frequency, it must get to a ridiculously low frequency, which would be undetectable anyway, wouldn't it?
Yeah, that's really it, and this is how many trillion years into the future, that the universe will fade away if it carries on in one direction, just expanding. Yeah, to me, it's more interesting to speculate that is our observable universe only in a region of the greater universe, which happens to be expanding, or the other, say another neighboring area of the same observable size as our universe, which is not expanding but is contracting. So, that's the whole question of, is the universe flat? From what we can see, it is, yes. But there might be completely the opposite in the neighboring universe, neighboring observable universe. I'm not talking about multiverse.
Yes, that's the whole thing.
Yeah. So, yeah.
Sorry, I have to go.
Yeah, so what's fascinating to me is what we can observe close to the edge of our observable universe and where you get anomalies and things which are different, great attractor, things, the Boots void. They talk about these. He talks about, again, the conventional view of the smoothness of the universe. And all of that, this whole cosmological model is based on there no being large structures above a certain size, which we now know is not true. There are massive structures which are being found, more and more of them all the time. So, the current model is just not accurate enough to properly describe. So,
No, yeah. Sorry, if the universe was expanding, would that mean more matter is being created?
Well, what is being created in the theory is dark energy. Dark energy stays at the same strength, even though space is expanding. Dark energy strength doesn't decrease. So that is what is being created.
Would it just be what we consider distance expanding?
Yeah. So I don't know. Yeah, there's a lot of this discussion in this direction could go on for all night, and you wouldn't really get anywhere. But it's very interesting. That's very interesting to me. And also, I think they've nailed down recently. You know, there was this Hubble. What do they call it? The question, the uncertainty. The one method of measuring the expansion comes out at 66 or 67, and the other method comes out at 73. But now using a couple of new methods and including with James Webb, they've actually nailed it down to pretty close to 70, being the accurate figure for the expansion rate of the universe. But I mean, there's a lot more to it than that. According to them, it wasn't always the same rate. It's slowing down in some places of our universe and speeding up in other places. Yeah, so nothing is simple. Nothing is simple, particularly in cosmology. Any finding you make, there's always a contra finding somewhere else in another corner.
Well, I think my mind has expanded as infinitely.
I like Penrose's idea that it's cyclical and it expands and then contracts again. Well, I'm not sure that's exactly what he proposed.
That's Fred Hoyle. His idea of continuous sort of creation. And
Yeah.
if we've all started off at the same time, it's quite reasonable to assume that we won't contact anybody through the SETI system before that they're likely to contact us at the same time.
Yeah, I think as far as aliens are concerned, I think the distances are against us. You know, it's unlikely that the distances in the universe are so enormous. You know, take them maybe they're 3,000 light years away, and it take more than that time to get a signal to us, and then we've got to get a signal back to them. How are you going to communicate with them? It's not possible. Yeah. And
so
again,
we're on our own.
Yeah, and Penrose's expansion, I think what his cyclical universe, it's actually, yes, it expands, but then another universe grows from that. So again, it's almost like an infinity thing, where the scale of the whole universe becomes irrelevant, I think, in his theory, and he actually proves it. So yeah, that's also very interesting if you read his books and stuff. So that this massive expanded scale of the universe then becomes like the size of a quark, never mind an atom, and then you're getting a whole new universe forming out of all these expanded universes, but on a much bigger scale. It's all a question of scale. The other thing I didn't like in this video, by the way, when he tried to talk about stuff being smaller than the Planck length, and I think it's a basic given that I don't know if Planck proved it or not, but that's why it's the Planck length, because nothing can be smaller than.
And I think it's like what we thought about the atom as well, that was going to be the smallest, and it's now just nothing compared to all the photons and different quarks and all the stuff that's come out of the minuscule side. You've got it on both ends. But to me, this kind of presentation is the mystery of it's the insignificance of our knowledge in terms of the whole picture. And I think that humility is a very important part of science, to constantly be not necessarily getting buried in the actual problem of it, but just to be aware of how small our knowledge is in terms of what it's all about. And I think we've seen already, just going from Hubble to Webb, they've now picked it 147 million light years away, where, as you said, there's no ammonia, therefore it could be water. And, there we've got out of those billions and trillions of whatever we're looking at through that telescope, we've now been able to identify something like that. So the fact that these questions are being posed by these people takes us to those limits of suddenly finding a technological manner that one can actually go now and find something at that distance, which wouldn't have been dreamt of, even with Hubble before that.
Yeah, all the new telescopes coming up in the next 5, 10, 15 years, very, very fascinating, including the European supergiant, whatever, telescope in Chile.
On a different plane, coming back to Earth and the solar system, are all the planets spinning roughly on the same plane? And what happened to the other ones that might have been north or south of us?
They are not all. I think Pluto is on a very different one.
Yeah.
And then I've just seen the titles of some YouTube videos. I haven't actually delved into them, but they found strong evidence of the existence of the 9th planet, another planet outside the Oort cloud.
Yeah.
So that'll be an interesting one to maybe have a look at and see what the evidence is there.
Yeah. And the other night, it must have been a satellite, which I reckon would travel at about 2 degrees a second. But now, it was from the east to the west, and I was wondering, the satellites, they can only circumnavigate the planet. They can't stay at the same parallel. They can't spin around a portion of the globe. They've got to spin right around the circumference of the globe.
Yeah, so the relatively low satellites, 400, 500, 600 kilometers above the surface of the Earth, have to go at a fairly high speed, like the ISS. To maintain their height above Earth, they have to go at a certain speed. And I think ISS, if I remember correctly, takes about half an hour to circumnavigate the Earth, or maybe an hour, something like that. So yeah, if you saw something going very fast, it'll be something low down. I think the altitude for geosynchronous orbit is about, if I remember correctly, about 20,000 kilometers. At that distance from Earth, then this speed to maintain the altitude above Earth is the same as the rotation speed of the Earth. So they stay in one spot, and those are all like the DSTV, I think. All the communications need to be in one spot.
But they can only go around the circumference of the Earth. They can't be off the.
Oh no! There are some that just depends on what they want to do. So there is a polar one. There's a couple that go around the poles.
Yeah, but I mean, it's got to go around the pole or around the equator or around the diameter of the Earth. So it can't be off center.
As they're going around, then sometimes either the Earth is rotating and they're going on a different path every time they go around. So in fact, yeah, the low Earth orbit ones, it's normal for them to not be on the same path. To be able to stay on the same path around the Earth, they actually have to have energy inputs all the time, which is obviously not efficient.
Yeah.
So it's actually normal to be not on the same path around the Earth for a low Earth orbit.
All right. Yeah. Oh, that's,
You're Heinrich is
yeah.
expert on all that sort of thing.
Yeah, yeah.
He has a lot of books about similar things.
Yeah. But unfortunately, he's on lunch now, so. Okay. Well, lovely. Thanks very much for
okay,
inspiring.
Your evening, and we'll see you next time. Any more comments, questions? Peter, are you going to send out the transcript to all the attendees for tonight? Is he gone?
It's 5 left.
Yeah, thanks again. Bye.
Peter's gone. All right, I presume he's going to send that out.
Sure.
Okay, those of you part-timers that are still here, thanks very much for attending. Thanks, Chris. I hope you enjoyed it.
Thanks very much. Yeah.
Thanks, Derek.
Yeah, thank you.
Yeah.
Thank you all.
Yeah.
Okay,
Cheers, all.
See you next time.
Bye.
Yeah, bye.
Bye.